In the sterilized, high-security laboratories of the Newport Naval Torpedo Station in Rhode Island, the Mark 14 steam torpedo was regarded not merely as a weapon of war, but as the crowning jewel of American naval ordnance, a technological marvel built with the precision of a Swiss watch and the price tag of a Rolls-Royce, costing the government $10,000 apiece in 1941 currency, a sum so staggering that submarine commanders were terrifyingly instructed to treat every shot as if they were firing a politician's salary into the ocean. The soul of this underwater missile was the Mark 6 exploder, a top-secret device protected by security protocols so draconian that even the captains who carried them were forbidden from inspecting the mechanism or understanding its true operation, for the Bureau of Ordnance, or BuOrd, had promised them a weapon of almost magical lethality that utilized a magnetic influence sensor to detect the steel hull of an enemy ship and detonate the warhead directly beneath the keel, breaking the vessel's back with a single expanding bubble of gas without ever needing to score a direct hit. This was the golden bullet, the theoretical guarantor of American victory, but when the Japanese Empire struck Pearl Harbor and sent the Asiatic fleet scrambling into the terrifying depths of the South China Sea, the theory collided with a brutal reality that would cost thousands of lives, a reality first tasted by Lieutenant Commander Tyrell Jacobs, a composite of the early aggressive skippers like Tyrell Jacobs of the Sargo, who found himself peering through the periscope of his Sargo-class submarine off the coast of the Philippines in late December 1941, his hands sweating on the grips as he lined up the crosshairs on a massive, plodding Japanese troop transport that was steaming south to land invaders on Allied shores. The setup was textbook perfect, the kind of firing solution that was taught at the submarine school in New London, with the target moving at a steady 10 knots broadside to the submarine at a range of less than 1,000 yards, a distance so close that a miss was mathematically impossible, according to the torpedo data computer, a sophisticated analog brain that whirred and clicked in the corner of the conning tower. Jacobs, suppressing the adrenaline that hammered in his chest, gave the order to fire, and the submarine shuddered as 4 Mark 14s were expelled from the forward tubes by blasts of compressed air, their steam turbines screaming to life as they raced toward the enemy at 46 knots, leaving visible white wakes that looked like fingers of death reaching for the Japanese hull. Inside the conning tower, the executive officer held a stopwatch, counting down the seconds to impact based on the speed and range, the crew bracing themselves for the earth-shattering concussions that would signal the destruction of the enemy. But as the second hand swept past the calculated moment of impact, there was no explosion, no breaking of the keel, and no column of water. There was only a sickening, hollow silence that stretched into an eternity. Jacobs watched in disbelief through the periscope as the white wakes of his expensive torpedoes passed directly under the Japanese ship and continued out into the open ocean, failing to detonate, failing to sense the magnetic field, failing to do anything but alert the enemy destroyers to his presence. On a subsequent attack run days later, he fired again, and this time he heard a muffled thud, a premature detonation as the magnetic exploder, sensitive to the Earth's own magnetic field variation near the equator, triggered the warhead 500 yards before it reached the target, sending a harmless geyser of water into the air that served only as a marker for the Japanese depth charges that soon began to rain down on his boat. The frustration on the boat was physical, a poisonous mix of fear and rage, for the crew realized they were risking their lives to deliver duds. But the true insult arrived when Jacobs returned to base and filed his action report, detailing the erratic behavior, the deep running, and the premature explosions of the wonder weapon. Instead of concern, the response from the Bureau of Ordnance in Washington was a blistering condemnation of the captain's competence, a haughty, bureaucratic memo stating that the Mark 14 had been tested exhaustively in the laboratories of Newport and could not possibly be defective. Therefore, the failure must lie with the men firing it, accusing the most elite sailors in the Navy of being unable to calculate a simple firing solution.
The admiral in charge of the Asiatic submarines, locking eyes with his exhausted and furious captains, realized with a sinking dread that they were fighting two wars, one against the Japanese Imperial Navy, which was dropping real explosives on them, and another against their own ordnance department, which had sent them into battle with a golden bullet that was nothing more than a $10,000 piece of useless clockwork, a technological hubris that would leave the American submarine force toothless during the most critical months of the war.
By the summer of 1943, the rage simmering within the submarine force had hardened into a cold, cynical despair. For the captains had learned through bitter experience that their greatest adversary was not the Japanese destroyer, but the Bureau of Ordnance in Washington, which continued to insist with blind, aristocratic arrogance that the Mark 14 torpedo was flawless, despite hundreds of patrol reports to the contrary. The breaking point, the moment when the anecdotal evidence transformed into undeniable statistical proof, arrived in the lonely waters west of Truk on July 24, 1943, aboard the USS Tinosa, commanded by Lieutenant Commander Dan Daspit, a methodical and disciplined officer who was about to conduct the most expensive and infuriating ballistics test in naval history. Daspit had stumbled upon a submarine commander's dream, the Tonin Maru No. 3, a massive 19,000-ton whale factory ship converted into an oil tanker, the largest prize in the Japanese merchant fleet, which had been disabled by a previous attack and was sitting dead in the water, wallowing like a wounded leviathan. There were no destroyers escorting her, no aircraft buzzing overhead. She was a stationary target on a calm sea, offering Daspit the chance to execute a firing solution so perfect it belonged in a textbook. After firing 2 initial torpedoes to disable the ship's engines completely, Daspit maneuvered the Tinosa into a position of absolute geometric perfection, bringing the submarine to a halt just 875 yards off the tanker's beam, exactly perpendicular to the hull, to ensure a 90-degree impact angle, eliminating any possibility of a glancing blow or a deflection. The stage was set for an execution, and Daspit ordered the torpedoes fired one at a time, allowing the crew to track each fish and observe the result with the scientific detachment of a laboratory experiment. The first torpedo hissed out of the tube, its wake drawing a straight white line to the massive black wall of the tanker's hull, and the crew in the conning tower braced for the explosion, but there was none. Instead, there was a dull, metallic clank, a sound like a sledgehammer hitting an empty oil drum, audible even through the Tinosa's pressure hull, followed by silence. Daspit, assuming a rogue dud, fired again. Another wake, another perfect run, another clank. The scene inside the submarine descended into a surreal nightmare as Daspit, his face tightening with a mixture of disbelief and fury, ordered the tubes reloaded and fired again and again and again. He fired at the bow, he fired at the stern, he fired at the midships, pouring the entirety of the submarine's arsenal into a sitting target that refused to die. In total, Daspit fired 15 Mark 14 torpedoes at the Tonin Maru No. 3, a barrage that cost the U.S. Navy $150,000 and should have reduced the tanker to splinters. The result was 13 confirmed hits that failed to detonate, 13 distinct thuds of steel impacting steel, and 2 torpedoes that exploded but caused only superficial damage. It was a statistical impossibility under the laws of probability, unless the weapon itself was fundamentally broken. Daspit, watching the Japanese crew on the deck of the tanker scrambling in confusion at the Americans throwing metal logs at them, realized with a sickening clarity that the perfect 90-degree angle he had so carefully arranged was actually the problem. The contact exploder on the nose of the torpedo was crushing itself upon impact before the firing pin could trigger the fulminate, jamming the mechanism rather than detonating it. He had hit the target too square, too perfectly, and the weapon had failed because it was too fragile for the violence of its own impact. With 1 torpedo remaining in the stern tubes, Daspit made the command decision to cease fire, not out of mercy, but out of a need for evidence. He would not fire the last fish. He would bring it back to Pearl Harbor like a smoking gun,
a tangible piece of metal to shove onto the desk of the Admiral to prove once and for all that the men of the Silent Service were not incompetent liars, but were being sent to war with a weapon that was effectively a dummy. As the Tinosa turned for home, leaving the Tonin Maru floating mockingly in the distance, the ghost of the opportunity lost weighed heavy on the boat, fueling a mutinous anger that would finally force the Navy to confront the betrayal of the deep.
The war for the soul of the American submarine force was not fought solely in the combat zones of the Pacific, but in the sweltering, fly-blown harbor of Frenchman Bay in Western Australia, and later on the concrete cliffs of Pearl Harbor, where Rear Admiral Charles Uncle Charlie Lockwood, the commander of Submarine's Pacific Fleet, decided to declare open rebellion against the bureaucratic aristocracy of the Bureau of Ordnance. Lockwood was a commander who regarded his submarine crews with a paternal fierceness, greeting them at the pier with crates of cold beer and fresh fruit, and the mounting casualty lists combined with the reports of dud torpedoes filled him with a cold, simmering rage that could no longer be placated by the polite, typed memos from Washington insisting that the Mark 14 was functioning perfectly. Following the initial failures in 1942, where captains reported torpedoes passing harmlessly under targets, BuOrd had smugly suggested that the submarine commanders were simply inept at estimating range, an insult that drove Lockwood to conduct an experiment of undeniable empirical simplicity that would shatter the theoretical arrogance of the engineers. He ordered the submarine USS Skipjack to Frenchman Bay and purchased hundreds of yards of heavy-gauge fishing nets, which he draped across the channel like an underwater tennis net, creating a soft, permeable barrier that would catch the truth without destroying the evidence. He then ordered the Skipjack to fire war-shot torpedoes, minus the explosives, but equipped with calcium chloride heads to leave a smoke trail, directly through the nets at various range settings. The result was a piece of physical evidence that could not be debated away. The holes in the nets were consistently 11 feet lower than the depth set on the torpedo's dial, proving that the Mark 14 ran deep, dangerously deep, passing beneath the keels of the destroyers and cruisers it was meant to kill. When Lockwood sent this irrefutable data to Washington, expecting an apology and a fix, the Bureau of Ordnance disputed the calibration of the nets, claiming the test was unscientific, a response that solidified Lockwood's conviction that he was dealing with men who preferred to lose a war rather than admit a mistake. But the deep-running issue was only the first layer of the rot. The return of the USS Tinosa in the summer of 1943, with its logbook detailing 15 shots and 0 detonations against a sitting duck, revealed a second, more terrifying flaw: the contact exploder itself. Lockwood, now operating out of Pearl Harbor, looked at the Tinosa's last torpedo, the one Daspit had brought home, and realized that the perfect 90-degree hits were actually the problem. To prove this, he enlisted the help of Commander Swede Momsen, a maverick engineer and diving legend, to oversee a series of tests that would replicate the violence of impact. They couldn't fire torpedoes at a real ship, so they decided to bring the impact to the torpedo. On a cliff overlooking the submarine base, they constructed a 90-foot tower and hoisted a Mark 14 warhead filled with concrete to simulate the weight of explosives, positioning it over a massive steel plate armor taken from a scrap pile. The premise was simple Newtonian physics. Dropping the warhead from a height of 90 feet would generate the same kinetic energy as a torpedo striking a ship's hull at 46 knots. As the first warhead plummeted and struck the steel plate with a deafening clang, the observers rushed forward to check the result, finding exactly what Daspit had experienced. The warhead had crushed, the nose was deformed, but the firing pin had not triggered. It was a dud. They repeated the drop again and again, adjusting the angle, and discovered the fatal paradox of the Mark 14's design. The firing pin mechanism was housed in a heavy block designed to be robust, but the laws of inertia dictated that upon a perfect 90-degree impact, the friction generated by the crushing of the nose cone was so immense that it clamped the heavy firing pin guides shut before the pin could move. The torpedo was essentially jamming itself because it hit too hard. When they dropped the warhead at a glancing, oblique angle, a bad shot, the friction was less and the pin fired. This was the smoking gun.
The Bureau of Ordnance had designed a weapon that punished accuracy and rewarded sloppiness. Lockwood stood over the twisted metal on the concrete slab, the physical proof of the betrayal lying at his feet. The golden bullet was a fraud, a weapon that ran too deep, exploded too early with its magnetic influence, and jammed when it actually hit the target. The Admiral realized that for nearly 2 years he had been sending his boys into the lion's den with wooden swords, and the blood of every lost submarine was on the hands of the men who had refused to test their own invention. There would be no more memos to Washington asking for permission. Lockwood decided then and there that the Pacific Fleet would fix the weapon themselves, using the resources of their own machine shops and the ingenuity of their own sailors, effectively mutinying against the established logistical order to forge a weapon that actually worked. The net had caught the lie, and the drop test had crushed the excuse. Now the only thing left was to rebuild the arsenal before the Japanese could capitalize on the reprieve they had been gifted by American incompetence.
The autumn of 1943 at the Pearl Harbor submarine base was defined not by the pomp of parades, but by the grit of an industrial insurgency, as the Submarine Force Pacific Fleet, under the orders of Admiral Lockwood, effectively seceded from the technical oversight of the Bureau of Ordnance to conduct the greatest do-it-yourself weapons modification program in the history of the United States Navy. The first phase of this rebellion was administrative but absolute. Lockwood issued a fleet-wide directive ordering the deactivation of the Mark VI magnetic exploder, the highly classified secret sauce that Washington had spent millions developing. The order was simple and brutal. Torpedo men were instructed to open the access handhole on the warhead and physically disconnect the magnetic influence mechanism, rendering the $10,000 electronic brain inert and transforming the Mark XIV into a simple, dumb contact weapon. This was heresy to the engineers in Newport who still believed in the theoretical perfection of the magnetic field detonator. But to the crews loading the fish, it was a liberation, ensuring that their weapons would no longer explode prematurely halfway to the target or run harmlessly beneath the keel waiting for a magnetic signature that might never trigger. However, the deactivation of the magnetic exploder left the fleet relying entirely on the contact exploder, the very mechanism that the drop tests had proven was prone to jamming on perfect 90-degree hits. The solution to this mechanical failure did not come from a laboratory with white-coated scientists, but from the grease-stained floor of the submarine base machine shop, where Commander Swede Momsen and his team of master machinists stared at the disassembled firing pins of the Mark VI mechanism. The problem was Newtonian. The firing pin block was too heavy, and the guides holding it were too tight. When the torpedo hit a ship's hull at 46 knots, the massive deceleration force caused the heavy firing pin to lag behind due to inertia, while the guides were crushed inward by the impact, pinching the pin and freezing it in place before it could strike the fulminate cap. To fix it, they needed to reduce the weight of the firing pin and the friction of the guides, effectively lightening the trigger pull of a 2-ton missile. The machine shop became a hive of frantic, subversive activity. The machinists realized that the standard steel firing pins were the culprit. They were simply too massive. They needed a material that was strong enough to hold the spring tension, but light enough to fly forward instantly upon impact, outpacing the crushing forces of the collision. Aluminum was the answer, but in the resource-starved Pacific of 1943, aviation-grade aluminum rod stock was a precious commodity reserved for repair of aircraft, not available for unauthorized experiments on torpedoes. In a twist of irony that would have delighted a Greek tragedian, the solution lay in the wreckage of the enemy itself. The machinists turned their eyes to the boneyard at Ford Island, where the twisted carcasses of Japanese A6M-0s and Val dive bombers, shot down during the attack on Pearl Harbor or subsequent raids, lay rusting in the sun. The propellers of these enemy aircraft were forged from a high-grade, lightweight aluminum alloy that was perfect for the task. The order went out, and the scavengers descended on the scrap heaps, cutting sections from the enemy's wings and props, bringing the metal back to the submarine base where it was melted down and cast into rods. The lathes turned day and night, shaving away the heavy American steel designs and replacing them with the new,
lightweight Pearl Harbor special firing pins. These new pins were machined to be as light as a feather compared to the originals, and the guides were shaved down to allow for more slop, ensuring that even if the nose cone deformed on impact, the pin would still slide free. BuOrd in Washington was apoplectic when they learned of the modifications, firing off angry cables warning that unauthorized tampering with the firing mechanism would void safety protocols and endanger the crews. But Lockwood, holding the physical evidence of the crushed duds in his office, ignored them with the stony silence of a man who was done asking for permission. He authorized the mass production of the new contact pins, and within weeks, the mutiny had produced enough conversion kits to equip the entire fleet. Down in the torpedo rooms of the Gatto and Belau-class boats, the mood shifted from cynical resignation to a grim professional excitement. Torpedo men, stripped to the waist in the sweating heat of the boat, disassembled their warheads, tossing the heavy steel pins into the scrap bin and sliding the shiny, lightweight aluminum replacements into the breech blocks. They were effectively rebuilding the weapon at the pier, stripping away the over-engineered gold-plated failure of the peacetime Navy and replacing it with a rugged, field-tested mechanism forged from the scrap metal of the enemy they were hunting. The torpedoes that slid into the tubes were no longer the golden bullets of the Bureau. They were the working man's fish, ugly, modified, and dumbed down, but for the first time in the war, they were lethal. As the submarines cast off their lines and headed back towards the Empire, the captains felt a new sensation in the pits of their stomachs: confidence. They knew that if they could put the crosshairs on the target, the weapon would do the rest. The era of the dud was over. The mechanics fixed what the scientists couldn't, and the Japanese merchant fleet, which had enjoyed a miraculous reprieve for 2 years due to American incompetence, was about to face a correction of terrifying violence.
By the dawn of 1944, the Pacific Ocean had transformed from a vast, frustrating hunting ground into a slaughterhouse of unprecedented efficiency. As the United States submarine force, armed finally with a weapon that honored their courage with functionality, unleashed the silent revenge upon the logistical arteries of the Japanese Empire. The change was not gradual. It was a sudden, violent spike in the graph of destruction that baffled the Japanese Naval Command, who watched helplessly as their convoy losses skyrocketed from manageable attrition to catastrophic hemorrhage in the span of a few months. We returned to the cramped, red-lit conning tower of a Belau-class submarine prowling the Luzon Strait, commanded by a veteran skipper who still carried the psychological scars of the dud years, a man who had watched perfect shots turn into hollow clanks for 20 months. Tonight, however, the geometry of the engagement was different. He was tracking Convoy High 81, a vital stream of tankers carrying the lifeblood of the Empire, oil from the East Indies, back to the desperate refineries of the home islands. The setup was familiar: the radar plot, the approach at surface trim to maximize speed, the frantic calculations of the torpedo data computer. But when the order to shoot was given and the new, modified Mark 14 torpedoes hissed out of the tubes, the result was a vindication that shook the ocean floor. The first torpedo, equipped with the scavenged aluminum firing pin and the disabled magnetic exploder, struck the 10,000-ton tanker amidships. There was no premature detonation, no deep run, and no dud. There was a blinding, jagged flash of orange light that illuminated the horizon like a false sunrise, followed seconds later by a concussion so violent it knocked bottles off the shelves in the submarine's wardroom. The skipper, glued to the periscope, didn't see a ship sailing away unscathed. He saw a pillar of fire climbing thousands of feet into the night sky, the enemy vessel breaking in two as its spine snapped under the physics of a properly functioning explosive. It was a scene repeated across the Pacific, from the Yellow Sea to the coast of Bungo Suido. The working man's fish was doing its job with a grim reliability, achieving a hit-to-sink ratio that terrified the Japanese merchant marine. The psychological impact on the enemy was total. Japanese sailors who had previously joked about the thumping American torpedoes now refused to sail, knowing that a periscope feather in the water meant certain death. The blockade tightened around Japan like an iron noose. In 1944 alone, American submarines,
operating with the fixed torpedoes, sank over 600 Japanese ships, totaling nearly 2.5 million tons, more than triple the tonnage of the previous years combined. The strategic consequences were apocalyptic for the empire. In Tokyo, the lights began to flicker and dim as power plants ran out of coal. In the shipyards of Kure and Nagasaki, battleships and aircraft carriers sat rusting at the docks, unfinished and immobile, because there was no steel to build them and, more critically, no fuel to move them. The silent service was effectively starving the war machine to death. The scarcity of raw materials became so acute that the Japanese government began melting down temple bells and pots to make bullets, a direct result of the submarine blockade that had severed the shipping lanes. The triumph, however, was laced with a bitter, melancholic fury for the men of the submarine force. As they returned to Pearl Harbor or Midway, their conning towers painted with rows of Japanese flags denoting kills, the celebration was always tempered by the ghosts of the boats that hadn't come back, the gudgeon, the grayback, the tang, crews that might have survived if they hadn't been forced to fight with defective weapons for 2 years. Admiral Lockwood, standing on the pier to welcome the returning boats, knew that the victory had been bought at an exorbitant price. The scandal of the Mark 14 was not just a story of engineering failure. It was a tragedy of bureaucratic hubris that had prolonged the war and cost thousands of American lives. The golden bullet had eventually worked only because the men in the field had rebelled against the men in the lab, taking the hammer and wrench to the problem themselves. As the war ended and the U.S. fleet sailed into Tokyo Bay, passing the wrecks of the Japanese Navy that had been immobilized by the lack of fuel, the submarine force could look at the devastation and know that they had been the true architects of Japan's collapse. They had strangled an empire from beneath the waves, turning the ocean against its masters, proving that while the atomic bomb ended the war, it was the humble, modified Mark 14 torpedo, fixed by the hands of angry machinists, that made the victory possible. The silence of the deep had finally been broken by the roar of success, leaving the broken hull of the Japanese merchant fleet as the final testament to the sailors who refused to accept a broken weapon.